Hello friends, welcome to engineering tutorial. So again, here we have a question on error analysis of non-unity feedback systems. So here we have a system with forward path transfer function gs is equal to 1 by s square into s plus 12 and feedback path transfer function hs is equal to 10 into s plus 1 by s plus 5, and we have to find out the steady state error due to unit ramp and parabolic inputs. Okay, so again, before dealing with such systems, first we have to write out the error equations for non-unity type feedback systems. So that is given by kh es is equal to rs minus kh cs, where cs is the output, rs is the input, es is the error signal, all expressed in s domain, Laplace transform of the time domain signals. So here this kh term is very important, which is the DC gain of the feedback path transfer function. Kh is equal to limit s tends to 0 hs. So that is equal to limit s tends to 0 10 into s plus 1 by s plus 5, which is equal to 10 into 0 plus 1 by 0 plus 5, which is 10 by 5, which is equal to 2. Here the DC gain kh is equal to 2. So here we have to simplify it a bit like we did in all the previous cases. So it is rs by kh minus cs. Again, when we take rs common, it becomes 1 by kh minus cs by rs. Cs by rs is nothing but the closed loop transfer function of a control system, and that is rs into 1 by kh minus gs by 1 plus gs hs, this much. Okay, so here we are given two inputs, isn't it? Two inputs were given, first unit ramp and then parabolic. So here for that what we have to do is that first we have to determine this much part, this much portion, okay, 1 by kh minus gs by 1 plus gshs. This much portion when we find out, then we can substitute rs with 1 by s square for ramp input and 1 by s cube for the parabolic input, unit parabolic input, and we can find out the error es. So first the important thing is to find out this much portion, 1 by kh minus gs by 1 plus gs hs. Okay, so here we have to substitute the values. Kh is to 1 by 2 minus gs is equal to 1 by s square into s plus 12. Okay, so be very careful when solving these kinds of expressions, because first of all they are lengthy, and when it becomes lengthy it is very easy to make mistakes. Mistakes happen, okay, and this is gshs 10 into s plus 1 by s square into s plus 12 into s plus 5, this much. So then it becomes 1 by 2 minus 1 by s square into s plus 12 by, here it becomes s square into s plus 12 into s plus 5 plus 10 into s plus 1 by s square into s plus 12 into s plus 5. Okay, so now see, s square gets cancelled, s plus 12 gets cancelled. This s plus 5 will go to the numerator. So this will become 1 by 2 minus s plus 5 which goes into the numerator, okay, s plus 5 which goes into the numerator to the top by s square into s plus 12 into s plus 5 plus 10 into s plus 1, okay. So this expression finally becomes 1 by 2 minus s plus 5 by the denominator, when you evaluate, when you solve it, becomes s to the power 4 plus 17s cube plus 60s square plus 10s plus 10, this much. So we will further solve it. So I am doing it here, okay, I am taking it here from this point, okay. So here it becomes 2 into s4 plus 17s cube plus 60s square plus 10s plus 10. See, I have solved it directly because I have already solved it. So if you solve this, you will find the same result. Unnecessarily it will it will take a lot of time just to show you these steps. Directly I have written it in the denominator, this you will get the same result, okay. So this now becomes s to the power 4 plus 17s cube plus 60s square plus 10s plus 10 minus 2 into s plus 5, which is minus 2s minus 10, this much, okay. This 2 goes gets multiplied with s plus 5. So then it becomes s4 plus 17s cube plus 60s square, 10s minus 2s becomes 8s, 10 gets cancelled, 10 minus 10, this gets cancelled. So this is only 8s by 2 into s4 plus 17s cube plus 60s square plus 10s plus 10. So this is the expression that we wanted. This 1 by kh, this red portion 1 by kh minus gs by 1 plus gshs. This is what we wanted. So now we have got this expression. We can substitute rs, get multiply it with this to get es, and then use final value theorem, limit s tends to 0 ses, to get the error. Okay, so first for ramp input, okay, first for ramp input will do. Ramp input, unit ramp input we are applying RT is equal to T, RS is equal to 1 by how much? S square. So we'll multiply this to get ES is equal to RS into 1 by KH minus GS by 1 plus GS HS, isn't it? So here it will become 1 by S square into this much, S4 plus 17S cube plus 60S square plus 8S by 2 into S4 plus 17S cube plus 60S square plus 10S plus 10. We know steady state error is equal to limit s tends to 0 ses, final value theorem. So here when we do it, limit s tends to 0, s multiplied with this much, s into 1 by s square into s4 plus 17s cube plus 60s square plus 8s by 2 into s4 plus 17s cube plus 60s square plus 10s 10. Okay, this get cancelled, become s, this 1 by s gets divided throughout the numerator. So that gives us s cube plus 17s square plus 60s plus 8 by, the denominator is the same, 17s cube plus 60s square plus 10s plus 10. So here we have to do limit s tends to 0 this much. So it becomes, all these terms, they become 0. This becomes 0, this becomes 0, this becomes 0. Here this one becomes 0, this one becomes 0, this one becomes 0, this one becomes 0. Only this much remains. So this finally the result is 8 by 2 into 10, which is 4 by 10, which is 0.4. So the steady state error for this non-unity feedback system for unit ramp input is 0.4. So this is for ramp input. Then we have parabolic input. So for parabolic input, again the process is the same, okay, the process is the same, just we have to substitute Rs with 1 by s cube. Rs with 1 by s cube, we have to substitute it with that. So here it becomes Es for this is for parabolic input. Okay, for unit parabolic input, RT is equal to half T square. Rs is equal to 1 by s cube. Okay, so here it becomes Es is equal to 1 by s cube into this much. Okay, s4 plus 17s square s cube, s4 plus 17 s cube plus 60s square plus 8s. So these are the, these lengthy expressions. You sometimes you get frustrated with writing the same thing and you make some mistake somewhere, and that will give you the wrong result. Okay, so always be careful. I know it's lengthy, but that's the way it is. So 10s plus 10. Then steady state error, limit s tends to 0, s Es. So this will become s multiplied with this, it will become 1 by s square. Okay, so let me do one thing. This. Okay, so here when you do this, we multiplied s with Es. So when s gets multiplied here, okay, when s gets multiplied here, it becomes 1 by s square. So then this 1 by s square, it will get divided throughout this numerator. Okay, it will get divided throughout the numerator, and that will give us equal to s square plus 17s plus 60 plus 8 by s by 2 into same thing, 2 into s plus 4 s4 plus 17 s cube plus 60 s square plus 10s plus 10. So again, this always remember, this is limit s tends to 0. Here also limit s tends to 0. When all the s is substituted with 0, this becomes 0, this becomes 0, and this in the numerator becomes 0, 0, 0, 0. And here when s becomes 0, it is 8 by 0, which gives us infinity. So when there is infinity in the numerator, it means no matter whatever it is there, other expressions in the numerator, or there something is there in the denominator, it will be infinity. Okay, it will be infinity, the result will be infinity. So here the steady state error for this non-unity feedback system for unit parabolic input is infinity. So here again, in these kind of questions, the important thing is to have patience to solve these lengthy expressions, because I know it is tiring to write the same expressions over and over again, just a difference of the power of s, and then you have to substitute the the values, and then you have to put the final value theorem by substituting rs with the particular input which is given, and then get the result. Okay, so this is another question on non-unity feedback system error analysis. So I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to engineering, science and technology. Have a great day. Thank you very much.